Welcome everyone. Hopefully you're in this session because this is a problem you're interested in, not just because there was nothing else interesting to go to. I hope. This session's a little bit different from your normal, I was going to say tech ed, your normal Ignite session. I'm not really going to be showing any code. I know it's always fun to look at other people's bad code. It's always fun to show my bad code, and trust me, I've written enough of it in my time. But what I wanted to talk about is especially since it's Friday, you guys are probably a little bit full with information after 3 days of getting stuff put into your head. Who's mentally tired, by the way? Yeah, okay, so thank you for your honesty. So we'll go through some things. The intent for this session is more to give you ideas and some stuff to think about over the long term rather than give me some specific knowledge about a specific toolkit or a specific approach or anything like that. So something you can then take back and talk with your teams about when you get back to the office on Monday, assuming you haven't been fired since then for not showing up to work, and then maybe improve from where you're at. Now, if I was just to ask you guys before we even start, how much technical debt you would have in your code bases, and we go from like a little to a bit to a crap load. Who's above my hand still? Yeah, okay, all right. Yeah. All right. So introductions, I'm Richard. I do this as all my things. You don't really care, we'll move on. If you need to look it up, and if I hit the clicker, let's go clicker. Let's go clicker. Oh, there we go, it's catching up. All right, it's gonna be like that for me. Okay, so what we're going to do in terms of the content, what we're going to talk about is what's technical debt, why it happens, and odds are the way you think of technical debt is not actually technical debt. We'll talk about that in a second. How do we quantify it other than what we just did then? How do we reduce it? Because if you've got a lot of it, you want to step down. And then how do we not make the problem in the future? What are some things we can do, things we can try to actually improve? So, clicker. There we go. All right, I'm just going to hold it right here next to the keyboard. All right, so firstly, technical debt is just a metaphor. Technical debt was a thing created by a guy or a metaphor created by a guy named Ward Cunningham at an OOPSLA conference back in 1992. So it's 25 years now. So as an industry, we're pretty quick at these things. Who's heard of Ward, by the way? A few of you? Okay, so Ward basically said this in his paper, and you can look it up online, there's an abstract there, and he says, although immature code may work fine and be completely acceptable to the customer, excess quantities will make a program unmasterable, leading to extreme specialization of programmers and finally an inflexible product. Okay, so immature code, there's plenty of seats by the way, just come in and push some people out of the way, or sit on their lap as well, that's fine too. Immature code doesn't mean it's code written by 3-year-olds. And I know you might look at some of it and wonder. And then you go to your Git blame tool or something like that and you realize that you're the person who wrote it. Immature code is code that doesn't yet reflect a full understanding of the product, or the solution I should say. Inflexible products, who's got that? Okay, I probably shouldn't ask these questions because everyone's arms are just going to get tired, aren't they? Just up and down the whole time. All right, and he says this, shipping code first time is a little like going into debt. A little debt speeds development, which is fair, so long as it's paid back promptly with a rewrite or some fixing. Oh my goodness, let's go clicker. All right, the danger occurs when the debt's not repaid, and every minute spent on not quite right code counts as interest on that debt, and entire engineering organizations can basically be ground to a halt because of technical debt. This is interesting, this statement. This is different than what you probably think of it as. We're talking about immature code. What Ward's saying is this. Greed is good. I mean, technical debt is good. It allows us to deliver something sooner. The intent of taking on technical debt is so we can put software in the hands of our customers, get some feedback on that, and figure out what to do properly and learn from it. The idea of releasing something that's not quite right, immature code, is so that we can figure out what mature code should be. It's all about learning. We want to improve our design. We want to improve the value delivered. If the way you think about technical debt is probably different to this. The way you think about technical debt is probably bad code. Would that be fair? So, this is awesome. I love my clicker. All right. So I would say that if you're who works in an agile manner, by the way? Or something that pretends to be agile? Okay, that's the rest of the room. Okay. And who's a cowboy developer? Maybe don't put your hand up for this one. You know what I mean by the cowboy developer, which is we don't actually care. We just go, yeehaw, write some code and deploy to product. From Visual Studio. Oh, I hate that button. All right, so acquiring, paying back technical debt's a desired expected behavior of healthy agile teams. I want teams to have technical debt for a short period of time. For those who don't know, by the way, I do training on behalf of Scrum.org as well, so I'm a Scrum trainer. I do coaching and all that sort of things, as well as the other things I do. So I work with teams all the time. I actually enjoy helping teams do development, help them improve their processes and practices and so forth. So we expect this sort of thing to happen. And guys, if you don't want to stand up for the next hour, feel free just to come in, and there's seats down the front, sit on the floor, I don't mind. Sit on the stage if you want. So technical debt, really, if you think about it then, is this. It's design complexity and cognitive load. Fair enough? It's not, I'm just going to give up on the clicker. It's not this. Okay? Now, how did this turn about? Most people think of it as that quick and dirty stuff. So what happened is that when Ward put the metaphor out, people misunderstood it and people started blogging about it. And of course, if it's on the internet, it must be true. And so he said in an interview a little bit later, a lot of bloggers have explained it and confused the idea or the metaphor with this concept that I can just write rubbish, I mean code poorly, rubbish, slap something out there, put it in production with the intent of doing a good job later. And of course, we all know that the road to hell is paved with good intentions and all that sort of stuff. And that's what happens. We put this stuff out there intending to come back and fix it later, and of course, what happens? Never fixes, right? We never get that done. The classic, let's write a proof of concept. I don't have to say anything more. All right. Ward actually says this: I'm never in favor of writing code poorly. This is the guy who created the metaphor. I'm never in favor of writing the code poorly, but I am in favor of writing code to reflect your current understanding, even if that understanding is partial. That's technical debt. And just to wrap it up a little further, he says this. This is in 2009. Dirty code is to technical debt as the pawnbroker is to financial debt. You ain't ever getting your code back. You know how this stuff works. You slap that bad code out there, you're never going to get the time to go back and fix it. So, your bad code is not technical debt. It's just bad code. It is. I know. You're all feeling slightly offended now. That's okay. We're here to help. And your bugs, by the way, aren't technical debt. They're just your bad code that doesn't work properly. All right, so we're fairly clear the difference between bad code and technical debt. Just to make sure, one final word from Ward. The whole metaphor depends on us writing code that's clean. If you can't write clean code in the first place, you can't take on the intended idea of technical debt, which is to release something that works well and then improve on it. We work in the Microsoft ecosystem. You might have noticed that maybe at the conference we're at. Microsoft practices this. I know. They release, you might call, immature products. The infamous V1. What version of a product do you have to be on before it's good? It's a normal practice. And it's not just Microsoft, we see it with all sorts of places. Google is famous for doing this. They throw stuff out there, they put the beta tag on it. It doesn't mean the code that they wrote is dodgy or bad or poor, just that their idea of how to implement it or their understanding of the solution isn't quite there yet. So they use it as a way to learn. That's a good thing. We want that behavior. What we don't want is for you to get there by just slapping anything out there and hoping for the best. That was. Okay, so thinking it again, I'm just reiterating just to make sure the point's clear. Technical debt is not these things. Okay, maybe don't own up if you recognize this. Quick and dirty code, corner cutting, copy paste development. I love this one. Love this one. Do I ask? Do I ask? Do you know anyone who does this other than yourself? Lack of tests. Oh, the room says. Oh. We don't write tests because, yeah, there we go, no time. Refactoring left for later. Bugs you'll fix later. An excuse for laziness. Yeah, it's all that. Now these are problems, right? These are definitely problems. They're just not technical debt. They're bad code. They're bad practices. That said, you know, really what we're talking about is it's a metaphor. What I want to help and talk about is technical debt in the pure sense, sure, but what we generally as an industry now regard as technical debt. The reason I wanted to just be clear on that is because the way you think about things changes. If you take on technical debt and you talk about it to the business as an immature an immature implementation, we're still trying to figure things out. Can we release it so we can learn? That's a different conversation than we just wrote some rubbish. Can we let our users be our testers? I know. But we changed the conversation as a result. I'd prefer you to talk the first way and make sure the second way we keep on top of. So how do we qualify or quantify, I should say, technical debt? Is it even possible? Can we have a unit of measure, like the number of debts per person or something silly? I'm not sure. Maybe we can look at things like a trailing indicator. So there's an interesting idea from this guy, Casper Jones, who says, you know, if you think about maybe the bugs found in development versus the bugs found 90 days after we've gone live, what's the ratio? If we're on top of our technical debt and our bad code, then maybe we only get, for every 100 bugs that we are aware of, only one of them makes it into production. Whereas average projects, according to the stats and more lies, is 15%. An interesting statement, that 15% is hovering near malpractice. That's a bit scary. It's a little bit extreme, but you know, sometimes you've got to go extreme to fix things up. Maybe we take on more a subjective measurement. We say, well, in an hour, if you think about if there's such a thing as an average hour, in an hour, how much time is spent solving customer problems, writing new code to come up with a solution for something that they want? How much is spent on design problems that you could have avoided by thinking twice, coding once, versus thinking nonce and coding once? And how much is just banging your head on the table? You've all seen that. I know, you've all seen the XKCD comic, anyone? The only measure of code quality is the number of WTFs per minute. Who's seen that? Okay. I like that one. We did this one before. How do you feel about your code quality? Maybe ask the team. I just asked you guys and you were all like, yeah, we're awesome. Where'd that last one? I was going to add asparagus as well, but I didn't want to go too far. Anyone at a 5? Or ever been at one? See, it is possible. And then you wrote your second line of code. Yeah. All right, objective measures. Something else. So this is where you take things like code analyzers and stuff, and you look at code coverage, cyclomatic complexity, class coupling, naming issues. Naming issues. Oh, naming issues. Anyone got the customer class? Yes? Or the database table named Presson? And then it's in there and people keep coding to it because of IntelliSense. They're just like P space, whatever, it's all good. It doesn't matter if it doesn't actually make a human word. It must be a good identifier. And then you try and find that thing in the code because you search for it under the right name. Code clones, we talked about copy paste before. These are things we can measure. And we can use tools like SonarQube. Who's looked at this, by the way? Anyone come across it? Do you use it? Anyone use SonarQube? Sweet, you're my friend. What do you guys use? Do you guys, the rest of the room, do you do anything for measuring quality other than using ReSharper? Or you look at ReSharper, it comes up with orange stuff, you disable all the rules, you don't care. As long as it's green, we're good. No rules are enabled, so ReSharper's always green. If you haven't looked at anything like this, this is a great tool. You can put it into your build pipeline, and you end up tracking things over time. This is the AngularJS one. You can jump on there. They've got a whole bunch of projects that they support. And you can see, we've got all these things. How many bugs, how many vulnerabilities, there's all sorts of measures. If you used FXCop in the past, it's a similar sort of thing. You can get analyzers to look at your .NET code, JavaScript code, Java code, C++ stuff. The C++ one's expensive, by the way. The rest of them are free. It's kind of weird. But look at these things and then understand where you're at. Or maybe don't. I show this tool to teams fairly regularly, and they want to run it the first time. And then they see the results. Oh, we don't want to look at that anymore. All right. There's other indicators. So it's all about indicators here. How fast are you going as a team? And what's happening over time. So velocity is the amount of new functionality we're delivering per sprint if you're doing agile, or per week, or whatever you want to do, whatever your unit of measure is. And what you find is a team that struggles with technical debt, they start here, and then over time, your velocity just goes down, 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 down. Your rate of delivery gets less and less and less. So of course, what do you do? Change jobs. We're hiring. You hire new people, which of course gives you more capacity, right? Except it doesn't, because those new people don't know how to do anything. And if your code is already terrible, they're just going to be in there creating their own special mistakes that they didn't realize they couldn't do. And so they're actually making it worse. And so your velocity goes like this and then goes because it then takes time for them to learn what they're doing to pick it up. But by then you've created so much more bad code. You then go, well, what should we do? We should hire more people. And this is how you can turn like a 10-person development team into 100 over a little period of time. It's great fun. It's good for that little empire builder in you. System availability and performance. Bad code generally results in systems that aren't available all the time. You can't stay up all the time. So you end up rebooting your web server every day because you've got memory leaks and bad performance and whatever else, and your performance is terrible and you don't know why, but you try and figure it out, but it's really hard to understand what those 1,500 lines of code are doing in that one method. This one. Yeah, I don't even have to laugh about that one. It's sad. But this one's a more interesting one. We made the joke about it, change jobs, but it happens. I was talking to a customer just the other week who got a contractor in, who's a government employee, by the way. So I'm going to pick on you guys a little bit, sorry. So this is private industry, and the guy looked at the code, looked at what it was, and went, and then went and took a job in government on a 15-plus-year-old code base, because what he was walking into was too terrible. That particular company can't retain people. They just keep going over and over and over again. The cost to an organization for this is massive. The hiring cost, the training up of people, and then losing them before you get any value from them, it's terrible. And it's reflected this way as well. Okay, I don't like seeing this. I want to enjoy the work I do. I figure if we're working until we're at least 95, which will be the retirement age by the time we get there, then we should enjoy what we're doing. The tech industry is a great, fun, and enjoyable industry. Let's make the most of it. Let's do things we enjoy. Let's be proud of the work we have. I like an environment where there's high morale, where we like to be proud of the work we're doing, not where we go, oh, more crap today. You know, and we just don't care anymore because the care factor's been beaten out of us. Okay, this one's also an interesting one. I see teams occasionally where everyone on the team has 20 years of experience. And that year that they've got 20 times is 1997. It's hard for these guys to catch up to where things are at. It's hard to move forward. It's a subtle form of not so much technical debt, but it's a problem because the team can't deliver new features. The customer's coming and asking for stuff. Let's build a web application. They're going, all right, so how do I do that in VB6? We want to change that sort of stuff. All right. In all these things, when we're looking at measures, regardless of how you measure, if it's subjective, objective, whatever else, you're not looking for specific trends over time, right? You're not. You are. Yes, you are. You're not looking for specific point-in-time measures. You're looking at the trends. You want to see these things improving. So I want to see my velocity going up. I want to see my number of code clones going down. I want to see my test coverage going up. You know, what's a good level of unit test coverage? 80%?
More than zero.
More than what you currently have today. If you've got 0, write 1 test, I'll be happy. And then write 2, and then write 3, and increase them. And just make sure, by the way, that your test is not, you know, do something and don't assert anything. I've seen this. We need to have 100% success in our tests. We need to have great coverage, so we write code that exercises the line of code and does no assertions. All right, so you should be able to ask your team if things are going well, how's our quality changed over the last, say, 3 months? And if they're saying it's so much better now, I can hardly believe it, that's awesome, that's what we want. No change, okay. Yeah. All right, so how do we reduce our technical debt? How do we start getting better? Anyone want to do this? Anyone propose this to their organization? Yeah, I can understand why. Did you try it, by the way?
Yep.
Did it work?
Yes. Yep, for the first sprint.
Most of the time, this actually doesn't even work. Most of the time, people go into a technical debt sprint, and they basically say, it's open slather, everyone, let's just go and fix stuff. And so people start fixing stuff, and we've got this person over here changing the entire architecture of how data access works. And this person going, oh, we can make it work with Angular 5. And this person doing something else completely, and someone else is just going through and fixing the Kasatama table. And they get to the end of their time box, and they go, oh, we need to all check it in. And then they try and smash their changes together. Unsurprisingly, nothing works, and no one knows what the hell's going on. And the person who was halfway through trying to finish their change took on too much, they bit off too much, and they didn't get it done. And you end up actually making it worse. And at the end of it, what do you deliver to your stakeholders and your customers? Nothing different. There's absolutely no new functionality and no real changes in terms of what we've done, but it felt fun. It's like a 2-week hackathon. Awesome. Don't do that. This one, the next one, you're going to probably recognize. Who's ever asked for the famous... Who's asked for this? Uh-huh. Keep going. Come on. There's more. We want to rewrite things, right? We get ourselves into a situation where the code is so bad that the only choice is to start again. So let's say we're rewriting, the average system that gets nominated for the rewrite is probably 5 to 10 years old. Okay, fair enough. Technology is getting a bit old. It's not much fun to work on anymore, so let's rewrite it so it's fun. And we propose, let's take this system and rewrite it. It took us 10 years to write this. How long do we need to rewrite it? 2 weeks. I was going to say 6 months, but you know. And so we give ourselves this arbitrary time. It's 6 months based on, I don't know what. Somehow we're going to replicate everything. At the end of it, if there's no changes in the current system, so for 6 months, no new features, At the end of it, we will deliver to you, dear stakeholders and customers, the same thing. with new bugs, new problems. Actually, it won't be the same thing, it'll be less, because you never actually finish it. The 6 months comes, the business goes, we've just got to start doing stuff again. And so they start pushing you to do work on the existing system. And the new one doesn't quite get there. So you end up with the new system and the old system running in parallel. And somehow now we have to integrate these two together. And we promise ourselves we'll go back and we'll finish everything at some point. Who's got 5 new systems currently going at the same time? Yeah, okay. I'm sorry for you guys. We can hug later. Mags Lorcan says this, the problem with rewrites is that it's a technical solution to a cultural problem. Ooh, this hurts. Bad code wasn't created only because the developers don't know how to code properly. It's created because of the culture and the environment you're working in. The culture and environment that created the 10 years of bad code is not changed when you create your 6 months of even worse stuff. We need to figure that, be aware of that, okay? So don't do a rewrite. You want to fix what you've got instead. Instead, try maybe the Boy Scout rule, which is leave the campsite clean and you found it. Think about this. So Tim Ottinger is talking, he has a good blog post about this. If you simply save the next person 2 seconds, make a small change, save the next person 2 seconds. When they read the code, when they come into that method the next time, it's 2 seconds easier to understand. Those savings increase over time. They take almost nothing as a developer to make. They're really quick, really fast, small incremental changes, but put together, they add up over time. And you can improve your application without ever having to go the rewrite or the technical debt sprint or anything else. Interesting thing, there is no point improving code no one maintains. Yet, if we're given a technical debt sprint, what do we start changing? The code no one's maintaining. We're not changing it. Why are we improving it? Well, because it looks ugly. But it works. Doesn't matter. It looks ugly. Change it. But now we've broken it. Don't do that. If you're in there changing something, make it easier. Fairly simple, fairly straightforward. Of course, that leads us to the R word. The R word, by the way, you spell with an A, not a U. Okay, I know. So Michael Feathers, who's heard of him? Working effectively with legacy code, talks about this sort of thing quite a lot. Series of small steps, each which changes the internal structure of the code without changing the external behavior. Most people, when they refactor code, end up redesigning code. End up changing the behavior that actually exists. If we do small things that change the internal design of the code without changing its external behavior, that's refactoring. That's where that 2 second saving type stuff comes into play. And he tends to talk about this in 2 forms, micro and macro refactoring. The micro refactoring obviously is small changes. So we're looking at stuff like this. What we talk, put my teeth back in, what we typically talk about when we're saying, extract method, for example, that sort of thing, or introduce parameter or something like that. Small change to improve the code we're looking at. For those things, go nuts. Do them as much as you want. No problem at all, as long as you're not changing the behavior of the existing code. The bigger stuff, where it starts getting into multiple files, starts working its way across the system, for those, only do 1 or 2 of those at once. If there's too many large refactorings going on, the team's going to get confused. You won't have a good feel for what's going on. Your risk of not having good understanding and then having people making mistakes because they didn't realize something changed is going to increase. We don't want that to happen. So, how do we do this? Iteratively, little bit, little bit, little bit. This is nowhere near as much fun. Oh, that's so sad. It's not sexy, it's not easy, it's not quick. I'm selling it, aren't I? I'm really selling it. And it comes with a cost. If you think about it, the bigger the loan, the longer the period it takes to repay, and the smaller the repayment, the longer this takes. It would be so nice if I could stand here and give you the just do this and everything will be magical rainbows and unicorns type stuff and you'll be fixed in 3 weeks, but it's not going to happen. This is very much the it won't happen overnight, but it will happen. Pantene, you can tell I'm a user. We get there eventually. So, rules about refactoring, making sure we stay on top of it. If you ain't got tests, don't refactor. I just let that pause for a second, sink in. Is there a question, or are you just owning up to the fact that there's no tests? Yeah, unless I do what? Write tests, there we go. All right, so here's the rule, or the approach. Regardless of the size of the refactoring, if it's small or not, introduce a test. Now, what I don't want to see are tests that test the implementation. I don't care about the implementation. What do I test? The behavior. Because any piece of software is comprised of the behaviors that we're delivering to our stakeholders. The way we deliver it, that's the internal, that's the thing we're refactoring, right? So introduce a behavioral test. Who's seen cucumber, gherkin syntax, given, when, then type stuff? That's what we want. We want tests that do that. Given this scenario, when this happens, expect these results. Make your changes, make sure the tests still pass. That's it. So the behavior tests that we're introducing, we would term those as pinning tests. Now in Visual Studio, there's ways to do this. The new, don't help me, I was going to say IntelliTest. Is that what it's called still? I can't remember. But anyway, you know where you can go into generate tests for code? You can do that and create what you could think of as pinning tests. And then make your changes and make sure those tests still pass. And if it's a macro refactoring, it's exactly the same. But you have to introduce more tests. The volume of tests change. And if you end up doing something like changing your database schemas, then you've also got to make sure that things like data migrations and other changes are all catered for. There's no point changing the schema, rolling out the updates and forgetting to actually migrate the data or never testing it. And I've seen this done before. You know, you roll out the update, you realize that you've screwed it up, you have to go back to your backups. You work at GitLab, you realize that you haven't actually provided any backups for 6 months, and then you write nice blog posts about how you screwed up and then recovered. All right, now it's not just about refactoring, obviously. Part of it is designing code that we'll expect to change. So let's take an example, designing code where we expect things to change. There's approaches to this. One of those approaches is feature flags. Fair enough. Feature flags are great. Who uses them? Who would like to use them but can't because their code's so bad? Okay. So the idea behind these is that in production, we can enable and disable a feature so that we can experiment and learn. So we could release immature code, give it to a subset of users, let them play with it without affecting anyone else. And how we implement it, we implement it fairly simply. It's just an if statement. This is using LaunchDarkly sample code. So I take a user, I get their details, I ask the LaunchDarkly system, this person, do they have the feature enabled or not? Okay, and if it is, we do whatever it is we need to do, and if not, we take the alternate path. Fairly straightforward, right? It's hard to mess that up. And I can have a team that's using feature flags, and they have a great code, awesome flexibility, and they can still drown in technical debt because we can do some bad things with flags. You end up with hundreds of flags. SAP, anyone? You can tell who's the SAP developers in the room. Too fine-grained, too many flags, it gets confusing. Remember, part of our technical debt is cognitive load, too much to think about. So therefore, we have issues. Naming issues again. We have a flag named Joe because Joe the developer wrote a flag. You think I'm joking. We duplicate flags instead of reusing them. Or we repurpose an existing flag don't deploy it properly and realize when we've used it the wrong way that we've broken something else. These are things that happen. The Knight Capital Group in the US is famous for having done this. They had a deployment they did with some feature flags. They turned a flag on, they deployed their software. They deployed to 7 out of their 8 servers. They reused the flag, and on the 8th server where that flag wasn't, or the code wasn't updated, that flag started selling stuff. They did share trading, and it cost them, I think, $400 million over about 70 minutes before they realized that they probably should turn the server off. I know, frightening, absolutely frightening. For fun, just go and read that because it's always good to laugh at someone else. We don't purge old flags over time. So the idea of a flag is we do this to improve understanding, right? It's kind of, let us take on some technical debt, immature code, figure it out, improve. And then once the feature's stabilized, what should you do? Get rid of the flag. But of course, this is kind of like going back and cleaning up your bad code. You don't get given time to go and clean things up. So we just leave the flag sitting there. And over time, we just accrue these flags and we end up right back at the start. Too many flags. These are all problems that can happen. So you can take great ideas and implement them well and then still mess up. Interesting challenges. So prevention, let's talk through prevention, preventing technical debt. So anyone had this conversation? It's really, really, really important that we do something. It's just a flag, quick, just put it in there, you can fix it up later. And then your response is? You pay my bills. Yes, you're always correct. All right, what about this one? I'm just going to look at the roof. I don't want to make eye contact. But it's not just between us and the manager. What about this one? I only put this one there because I do this. So these are all problems. Ouch, Richard. Don't say that. Bad code only exists because of us. No one else wrote that code. Your customer didn't come in and grab your keyboard while you were away, write the code and check it in under your name. You did this. I did this. I still do this. It only exists because of us. And like AA, the first step is admitting you have a problem or you might be the problem. So we need to fix things, okay? Now, it's interesting. Why do we let this happen? If you think about it personally, what are the situations where this has happened? It's generally because of our second line there. Yeah, sometimes we're human, right? We have a lazy moment. Oh, won't worry about it this time, and it slips through. Or we're tired because we've been, at Ignite all week and we drank heavily the night before, and or we just make mistakes because, hey, we're human. It happens. But normally, it's the second one. It's normally because of our responses to pressure, whether that's external, someone pushing us, or internal because we said we were going to do this by this point in time. And we try and get it done because we've got personal pride on the line to try and say that we can meet our commitments versus let's write good code. These are interesting. So then maybe what we want to think about when refactoring is not just refactoring code, but refactoring people, refactoring ourselves. Step 1, are you ready? Those manager conversations before that I showed up, that was asking permission to do your job properly. You don't need to ask permission. Hopefully most of you are highly paid professionals, intelligent people who know how to solve problems well. If someone else could solve the problem, they'd do it themselves. They wouldn't need you. So a customer comes to you and says, I need this done. You go, sure, I'll do it. You don't mention the fact that you're going to do unit tests or not because it's just part of development. It's just part of doing your job properly, part of making sure things stay maintainable. The idea of taking a shortcut to meet some arbitrary deadline now, and then we throw the code over the wall to the bug fixes usual team, BAU, is not professionalism. We wonder why we get treated as amateurs sometimes. It's because of our own behaviors. Definition of done. Who's heard of this? Okay, who has a good one? Less hands. Who actually follows it? No hands. Okay. You need to have a definition of done. You've got to stick to it. Henrik Nyberg, Spotify coach. If you've anyone read about the Spotify model and all these sort of things, for those who pay attention to this stuff, heard of Spotify? Might have seen it, yeah. Okay, he has this, a little bit of a ranting problem to the solution to technical debt, ranting post I should say, but it is amusing. It's pretty much stop it. Remember, who causes technical debt? Yeah, I know I do. Don't just point at me. Look at your navel, just here. We are the problem, right? So we need to just stop it. I know. Amazing. If you keep doing the same things that you've always done, you don't get any change in behavior. It's incredible, isn't it? So we need to stop doing the behaviors that lead us down the bad path. Some of that means we're going to have to get people to help slap us around occasionally, your colleagues. They're not going to enjoy it, trust me. They don't enjoy beating you up. But he says this, which is interesting. One of the fundamental principles of agile software development, and to be honest, any software development, is this idea of sustainable pace. If you're consistently creating rubbish, you're going to get slower and slower over time. You don't have a sustainable pace. You can't keep going at the rate you're going. And it's not good. I'll just skip through these because I just want to show this. You know, theoretically, this is kind of the idea that if we keep going at the rate we're going, sure, we might be going awesome at the moment, but we're gradually going to get worse and worse and worse and worse until we can't deliver anything. If we slow down a bit now and we take our time to do things properly, the intent is that we can maintain that pace consistently for a long time. And sure, in the next 6 months, maybe there's no real improvement. We actually do less than we might have done if we had kept taking our shortcuts. But in 12 months' time, we'll have delivered a whole lot more than we would have otherwise. This is the conversation to have. This is actually a business decision, total cost of ownership. You can talk through this from a dollar's perspective with stakeholders without a problem. And if you ever need help, for example, and you want to have someone else external come in and beat your stakeholders up and tell them why that you need to start changing your behaviors, I'm happy to be that person. I love coming in and having this conversation with people. It's great fun. But, you know, I enjoy that sort of thing. I'm kind of sick. So let's take some practical steps. All right, obvious things, right? Automate everything you can. Anything you're doing manually is taking time away from writing new code. It's stuff you don't need to do. It's a waste of time. Just automate that stuff, including quality checks. Whatever you can do to automate your quality checks, try and do that. You know, make sure your pipeline, your CI/CD pipeline does all those checks around those objective measures around cyclomatic complexity and so forth. And if your coverage goes backwards from the previous build, break the build. This is that discipline part, right? Being professional. Break the build. It's not a problem. Make sure most of your tests are really quick. I have teams that I know of that, you know, they have great test coverage, but their tests are all functional, automated, browser-driven tests. Great. All your code gets executed. You're proving things work through the UI. That's wonderful. Except your test run takes 8 hours. Salesforce. Anyone work with Salesforce? Okay. Have you seen how Salesforce tests their application? Everything is a functional test. 100,000 functional tests. To run their tests, they have about 50,000 servers running their tests because 100,000 functional tests take forever. Whereas if I had unit tests or tests that work just below the UI layer that were blindingly quick, I can get a massive sense of confidence in only a matter of minutes. I had a team where they were struggling to get their test run down, you know, to under a few hours. So one of the team members decided to spend about 6 weeks trying to figure out how to write the test framework to support parallelism so they could keep running their functional tests and have it run in about half an hour. And they just kept ramping up, vertically scaling the test box. So it became more and more expensive to run these things, slower and slower to execute, and they were wasting time trying to solve a problem that they shouldn't have made in the first place. Remember the think twice, code once thing? All right, editor configs. This is just a completely different example, but who in the team argues over spaces and tabs? Yeah. So here's the way to solve it. Anyone know what editor config? Anyone use it? A few people? Okay, so this is in 2017 by default, by the way. 2015, you can get a plugin. The idea is you have this little editor config file that just gives you these defaults, and then you take away the argument from the team, and you get consistency in your code base. A consistent look and feel to your code makes it easier for the next person to read. It's one of those 2-second saving things. Do that stuff. Now, talking of testing, by the way, obviously there's different types of things. So you can improve your test design. We can start off by actually writing them. I know. Avoid the implementation ones that I mentioned before. Limit your slow things. These are practical things that you can do today. Not a problem. But you can also address your culture. Remember, refactor the people that are writing this stuff. So remember that response to pressure? Either of these two statements, if you hear them, this is where you get to slap your teammates. If you say them, this is where they can have an intervention and beat you up. Because neither of these are good behaviors. This leads to sloppy bad code. We don't want that, right? Ward isn't in favor of writing bad code. He wants to write good code that doesn't reflect the full understanding yet. So if you do have those design decisions where you release immature code or a design you're uncertain of, that's okay. Just keep a track of it, reassess it, things like that. One of the worst things you can do as a team, by the way, is spend so long trying to think about which way is the right way. How many ways are there to do things in software?
Too many.
Yeah. And a team that spends all their time doing analysis paralysis and arguing over what might be correct, we don't know if this one's the best way or this one's the best way or this one's the best way. There is no best way. There isn't. There is a way that works. There are multiple ways that works. Pick one. Just pick one. And say, we did this because it seemed like the most expedient at the time, and we'll assess how it's going in the future once we get some feedback, and then we will learn from it. Iterative design, incremental improvements, perfectly fine. Code reviews. Who does peer reviews? Who thinks they suck? I agree. Most of them are a waste of time because of that example I showed before. Most of them are a waste of time. You end up with this, negative attitudes. The large reviews get glossed over because they're so big and they take time away from doing things, yet they're the ones that carry the most risk and have the most chance of having problems in them. Reviewers don't have the context of why something was written, so you have to spend time to figure it out, which generally involves asking the person who wrote it, what were you thinking when you wrote this? And they go, I don't remember. Inconsistent approaches between reviewers, personal preferences, kicking in, I hate underscores for private variables. Other people love them. They're weird like that. They're probably VB programmers. Poor devs choose friendly reviewers. Have you seen this behavior, by the way? Do you do this? The assumption that reviewer will check your work, or the assumption that if I'm reviewing someone else and I think they're a good dev, that they actually know what they're doing, so I don't pay as much attention. These are problems, and they let a whole lot of stuff slip through, which effectively makes most peer code reviews a waste of time. Ouch. Now, that said, bad experience doesn't mean it's the problem. The idea is still sound. So let's see what we can do to actually improve stuff. So let's stop doing peer code reviews. Good solution. Who likes that one? Everyone just gained 4 hours back per day. What about peer refactoring? Everyone's just going, what are you talking about, Richard? So here's the approach. You submit unrefactored working code for review. So you write the code, you make sure it works, but you haven't yet refactored it to make it clean. Your peer, instead of actually doing the code review, comes along and refactors the code. Interesting. figuring out the changes they made. You have a look at their refactoring and see if it still makes sense and see if the code is still understandable. And then you repeat those two until you're good to go, much like a normal peer review. Why would we do this? Why not just go, you know, you're nuts, Richard, you idiot, get off the stage. Think about it. If you have to refactor code, you have to understand it first. True?
We've actually
Well,
done this just recently, and I found it exceptionally valuable.
yeah, it's fantastic. As a reviewer,
But it's still a code review.
just don't forget the milk. As a reviewer, you can't read a diff log on screen and then snooze. Commit it. You actually have to pull the code down, you have to exercise it, you have to prove that it works, you have to understand the intent. So now we have two people who understand the code. And also, as a reviewer, you still feel like you're contributing. You know, as devs, we want to write stuff. I might not have written the first draft, but I can come along and I can refactor the existing code, so I feel like I'm making a contribution. Whereas if I just read code, I feel like I'm just doing admin work. Anyone else identify with that? It's just me. I hate doing peer reviews. Much rather go through and fix stuff as I see it. But it's still a slow process. So what could we do? Well, this is where people then start thinking about this one. Who does this? Who hates this? It's okay, you can put your hand up. Normal pairing goes something like this, by the way. The idea, you know, two people working at the computer to do something. One person codes and the other sleeps. Or there's alternate forms. Two people fight to prove who's the smartest. Yep, good, good. One person codes in silence. The other person's watching going, I don't know what you're doing, but I don't want to interrupt. Or the expert pairs with the novice. Yeah, okay. Yeah, you're doing it wrong, okay? Who's heard of strong style pairing, anyone? Okay, so the idea behind this is you have this driver-navigator approach. So if you think about rally car driving, you have the driver who's driving, then you've got the navigator who's sitting there reading the papers going, left 3, right 4, slow, over hill, something like that. They're basically giving instructions of where to go next and what's coming up. Both people are engaged. Both people are involved in what's happening. The idea behind this approach, put really simply, is the only way code gets to the screen is through someone else's hands. If you want to write something, you tell the other person what to do. You communicate the steps at a level they understand, they do it. Why does this work? Firstly, you've got no more passive or silent partners. I'm engaged as the navigator in terms of what I'm trying to do. The driver, whoever's on the keyboard and mouse at the time, is also engaged because they're listening and they're trying to figure out what's going on. And when they go, oh, hang on, they simply throw the keyboard back to you, and you become the driver, they become the navigator. And we can ping pong this way quite effectively, and it's really quick, and it's surprising if you've ever done this, just how awesome this is. The expert novice issue goes away. In fact, I can do this with a business person. I can sit down with a business person and have them writing code. They don't actually understand what they're doing.
So you can still write bad code.
Yes, it's a gift. But I can have them involved in what's going on. And when they have things like, you know, we're playing around with the UI, for example, they can switch to become the navigator and I'm the driver. And they're saying, well, can you move this here and that there? And have you ever done that, by the way? You sit with someone, they're telling you how to play around with the UI, move stuff around. That's effectively this. And it's an effective process. And of course, you eliminate that really long, slow code review process. I did not say that. So the risk is reduced, not eliminated, correct? I can still mess things up. But it also gives us more opportunity to find those 2-second savings as well. Have you ever paired with someone? And if you haven't, that's okay. Watch someone code. Who's a mouse user? Ooh. Oh, I so want to work with you guys. Someone who does their stuff on the keyboard, then they reach their hand over to the mouse, move the mouse up, they click the button to go F5, and then every step they're clicking, step. You do that with me, I'm like, stop it. Use your keyboard shortcuts. You drive me nuts because it's so slow. So if I'm navigating, I'm going to stop it. And if you're the driver, okay, what's the keyboard shortcut I have to use? You start learning the keyboard shortcuts. If you ever wanted to learn VI, there's ways. All right. Spending time to save time. So obviously business people look at this and go, hang on, I'm paying you guys to code. Why are you sitting together? Angry face. Okay, so I want you both coding features at the same time. So the red coder and the gray coder are both coding features. Red guy finishes first. That's great. Takes a little break, goes for coffee, starts on feature 3. Is feature 1 complete yet? Don't know. We're going to do a code review to figure it out. Feature 2 guy finishes. He takes a break, starts reviewing feature 1. They're going to fail it. The red dev, she's doing her stuff, takes a break. Gray coder, he hates doing code reviews. He's drained after it, so he takes a long break. Red dev, she's looking at feature 2. She's going to fail it when she's done because there's stuff to be fixed. Then gray coder picks up feature 3, reviews that. Feature 3 is done. They passed that. It's successful. Happy days. We've got 1 delivered. That's good. But of course, I hate code reviews. Now I've done 2 code reviews in a row. I haven't written anything. I've just spent all my time reviewing code. Man, my life sucks. And then they start fixing up the failed review they got before, and then is feature 2 done at this point? Don't know. There's still more to be done. The red dev, they finish adjusting feature 1. Is it finished yet? Don't know. We have to do another round of reviews. You know this story, right? We've all been there. Yet, if we do it together, sure, there's 2 people working at the keyboard, but the net time is largely reduced. By the way, I can make that top row work a lot faster than the bottom one. How do I do that? Don't do peer reviews. First thing that goes when time pressure comes is code reviews. Correct? And so our quality, of course, starts going down. You don't need permission to do your job properly. This is an easy discussion to have with people. All right. Now, a guy named Woody Zull, you may have heard of. He went crazy with this whole idea of pair programming and doing things. Anyone heard of mob programming? Okay. Anyone tried it?
Works well.
Yeah. The idea is to basically, instead of having 2 people at the computer, you jam the whole team in front of it. It's like, hang on, everyone's going, what the hell? It's surprising. This is one of those crazy ideas that just happens to work. The idea is that the whole team's there, and as a result, you don't have to know as much to be involved. And you don't have to wait for information. Everyone's there. What should we do in this situation? Here's a scenario we haven't thought of. What's the business rule here? Because we aren't just sitting there with coders. We're sitting there with the UI, UX people, the DBAs, the business person, whoever it happens to be. They're all in the room at the same time. They're all part of the team. And you know, most people would expect that this is going to increase cost massively. And when I first heard this, I went, yeah, hello. However, this happens. When you've got a whole lot of people looking at someone bumbling their way through stuff and doing mechanical, repetitive work, even at the small level, everyone's getting impatient. They're going, come on, there's got to be a better way to do this. Hurry up. And so the team starts looking for ways to improve how they work. And all this normal, boring stuff that you would mechanically just, gut through, as said here, becomes visible, and we eliminate that waste. Eliminating the waste means that people stay more engaged in what's happening as well, because there's no time to tune out. These are ideas. So, mob programming as a result means that if you want to maximize the intelligence of your team, that's fine. If you're trying to maximize the lines of code written by your developers, don't do this. But if you do that first approach, then IBM from the 70s just called. They would like you to go work for them. It's an idea. Probably the most important thing, though, for you guys, the takeaway from this section is experiment with different approaches. See what works. Think about ways to try and get more eyeballs on a piece of code sooner so that you can eliminate that debt. That transparency helps make sure that you don't write the bad code. So, other mechanisms, other things to try. Limit your work in progress. Who's a starter? They like starting stuff. They hate finishing. They're like this professional surgeon who comes in and fix up the patient, crack the heart, chest open, work on the heart. Nurse, you close up. And then we're done. Doctor Strange kind of stuff. This is, again, be professional. Only work on one feature at a time. I know it's going to ruin your whole thing of, I just want to start new. I don't want to finish because finishing's boring. But finish that one thing, because a whole lot of work in progress means that at some point you're going to check in that work in progress code and it's not going to be ready. So you're just going to drive up your bad code. What about branching? Who likes branching? This one should be obvious, right? Don't have long-lived branches. Because the longer a branch goes, that more ugly and time-consuming the merge is. And if someone's done a big refactoring while you've had your long-running branch, you've all been through this, right? And then you have the integration person who is, does anyone have that? Like the integration team member who has to take people's branches and merge them? I know there's organizations that do this, which is like a crazy idea. So you can write really rubbish code, you can write really rubbish code, and we'll give it to someone else to make it fit together.
We call it the release coordinator.
Yeah, don't do that. Premature optimization. So optimized code is complex code, right? And I see people do this. They try and optimize the CPU cycles for something that's making database calls. N+1 database calls, but make sure it goes really fast on the CPU. Even though every database call is costing us 300 milliseconds or something every time. And the whole sequence of operations takes 12 seconds. If we can optimize the CPU to save that 2 milliseconds, success. Complex code's hard to maintain. Obviously, if it's hard to maintain, it's easier to screw up in the future. And remember, we're talking about immature code. If the code isn't mature yet, don't optimize it. If you've gotten to the point where the code is mature and you can optimize it at that point, that's great. Do that. I'm not discouraging optimization or performance. Performance is a feature. But don't do it until the functionality itself is stable. Because then you've got tests around the code, and then you can prove that your optimizations, which are going to be refactorings, hopefully, are still keeping the behavior consistent. Make sense? All right. What else we got? Resist temptation. Okay, own up. Who likes adding frameworks and packages? I need to add two numbers together, so I went to NuGet and I downloaded the addition library. Yeah, you've all done it. Or you've just gone to a conference and you went to maybe the CQRS session. Great session, by the way. I learned a new pattern. I go back to work and I just apply it, whether it makes sense at that point or not. I learned about dependency injection and IOC, so I just threw another container in there. We've now got 12 containers in our application, and no one knows what's going on. But hey, I got to do my new coding pattern. Resume-driven development is a thing, by the way. Framework version 2 is out. It offers us no features that will help us. But hey, we need to upgrade anyway. Oh, and it made a whole bunch of our code obsolete, or obsoleted a whole bunch of methods our code used to call. So now we have to go back and fix all those. So we've got a perfectly fine application running on Angular 1. Angular 2's out, so what do? We put React in. Let's rewrite the UI again. Share what you learn with your team. This is a great way. We talked about skills. Do this. This helps. If the team has a better understanding of where they make mistakes or where they can be better, share that learning around. Brown bag sessions at lunchtime are a great way to do this. If I'm working with teams, I'll often write emails that say, I saw this in the code. Here's how we can do things a little better. If you spot this yourself, try it. That way it's asynchronous communication, but it's a worked example. Go to conferences. Good idea. Glad you're here. But when you go back, spend time to tell the team what you learned. Who's here with their entire team, by the way? Anyone? Awesome. Awesome. So I assume you're not all going to the same sessions. It's not like groupthink or anything like that. So when you get back, hopefully you're all sharing things from different sessions. It's not just what was a good session. Oh, it was all right. Yeah, did you learn anything? Yeah, I don't know. I was asleep at the time. It was Friday after the party. But go back and tell the team what you've learned. Share the knowledge. We like that sort of stuff. Or do a hackathon. If you go back and you really want to try that new design pattern or something like that, do a hackathon. Anyone done hackathons? Yeah, enjoy them? Because it's a chance to scratch your itch. As devs, we want to try new things. We want to play around with stuff, exercise ideas. So do that, but do it in a safe environment. That way your half-finished, half-baked implementation doesn't go to production. And you don't have to maintain that thing. You can learn the lessons from it, immature code, and then use what you learned to improve for the next time. Great way to do stuff. All right, and adhere to a definition of done. Works on my machine is not done. I know. Even if you're using Docker. Says me. And it applies to the whole product. So if you've got multiple teams, you need to make sure all the teams share the same definition and you're all being rigorous and disciplined about it. So just to recap, and then I'm going to throw it open to questions. Technical debt can be a good thing using the proper sense of technical debt, not your bad code definition. Bad code is never a good idea. We understand why it happens. Improve things through steady flow of continuous small improvements rather than trying to bite off big chunks of it. Increase your transparency, discipline, and professionalism. Support each other in your teams so that it's not just you as the lone wolf. Make sure everyone's on board together. And share your learnings, and that's pretty much it. I do want to say before I do open it up that you can still play around with things, and I know there's no prizes now for doing feedback, but I would definitely appreciate feedback. I like to know if this is valuable. Sessions like this in particular, which aren't purely technical and a bit more meta, I suppose, than anything else, at Ignites, if you like this sort of thing, ramp it up because it means that we're more likely to get things like this in the future. Other than that, thank you very much. I'll be around. That's things. So questions? All right. So who wants to share war stories? Got a question? Yeah.
Interesting on challenge of the refactoring.
Yes.
You made mention to not changing the external interface.
Behavior.
Also external behavior.
Yeah.
When that external behavior relies on side effects at various points,
Okay, so the question is, if I'm refactoring some code where I'm relying on external behaviors or external side effects, those side effects are part of the behavior. So you need to write, and it's a bit trickier, but you need to write some sort of test that proves that not only the behavior you expect is right, but that the side effect has also occurred. If you want to change that, then that's a new feature and it's a design change. It should be treated as more like a backlog item to fix this so we don't have the side effect. Yeah, it's awkward. Other questions? Did I see a hand? Yeah. What are some great branching models that I've worked with? Who uses Gitflow? How have you not shot yourselves in the face yet? My favorite branching model is the one where you don't branch, basically. But if I'm going to do branching, I will do a story branch or a feature branch. So I create a branch, I build the feature, I try and get that delivered as soon as possible, and then I merge down from master and then push that up once the merge is good. And that's it. So basically one branch for the thing I'm working on, end of story. So those like release branch and integration branch and all that sort of stuff, don't add the complexity you don't need. It's probably the most important thing. Don't add complexity you don't need. Question? Yeah?
Kind of question slash comment. You were talking about kind of a driver slash...
On the pair programming? Yep,
yeah.
Driver Navigator.
Yeah, to be perfectly honest, I really don't like that model. I've done that before where I've been the driver and someone's standing over your shoulder saying, if, open bracket, y, greater than 7,
Yep.
close bracket. I find that it's a bit more of a driver slash transcriber, and I find that it's frustrating and it makes you feel like you really don't know what you're doing.
Yep.
I avoid that.
Okay, so see this second part? Communicate at the level the driver understands. So if I just say, add an if statement that does this, that's enough. Let's add an if statement for just check if that variable is true or whatever the condition is. You can figure out the semicolons and all that sort of stuff yourself because you obviously know enough. So it's probably more that they've been communicating too detailed. But again, this is an experiment. If you don't like it and you can figure out another way in your team to have better productivity and better code quality, great. Blog about it because I'd like to know. Is that okay?
Yeah,
Yep. All right, question?
I'm just thinking those 2-second improvements you're talking about.
Yes.
Would you generally have them go through a different process, obviously not a branch for that?
No, just do them as you go. It's a small improvement. You're going to have your code because generally the 2-second improvement is in code you're changing. So it's going to get tested anyway. So not an issue there. Question?
Have you got any tips on trying to sell some of these ideas? You work in a team where people love to hang on to their knowledge and people don't like working remotely.
So the question is, do I have any tips for people who want to hold on to their knowledge and they've got like a little protection mechanism and a force field that says, if you get here, I'm going to shoot you with a machine gun kind of stuff. Close enough? Yeah. Because, we're not protective at all as devs about the code we've written, right? It's our soul on screen, right? And having someone else pick on your soul is not a fun thing to do. I would say be the example first and try to avoid coming at them hard. Because if someone comes at you hard about your code sucks, my initial reaction is going to be put the wall up, right? And say, you suck, and act like a 2-year-old. But it needs to be collaborative. Like, I'd like to show you how we could do this better. Can I do that? I'm asking permission to help first. And if they say no, okay, I'll come back and I'll ask again later. And I'll show that I can help others in the team maybe. And then we start, basically trying to work with the easiest people to change the behavior of the team first. And then my holdouts, the ones who are, always standing there frowning, you're all wrong. I've been doing my work in the industry for 45,000 years. I was coding before the abacus was invented. Those people, they're going to take time to come around to different ideas because they're generally the ones who, you remember that team skill and learning and currency of skills, I suppose? They're generally the ones who are a bit behind and feel like if they don't protect themselves, then maybe their job's at risk. And I'm not saying this is the scenario, but these are the things I tend to see. They feel like there's a threat to being open. So we've got to build that trust in the team first to show that this isn't about threatening each other or trying to expose bad behavior. It's about trying to improve. And it's a subtle but very important difference in the way we communicate. So hopefully that helps. Do I have any specific tips for the scenario you're thinking of? I don't know, because I'd have to see the people and understand their personalities. If you haven't figured it out now, I tend to use humor or bad humor as a way of trying to get through those barriers. And I try and make sure that I'm always the one showing my mistakes first so that it's okay to show that you're a problem. Are there more questions? Yeah. How do I deal with the cowboys? Take the horse away? If they're wearing chaps in the office, tell them to go home and get dressed properly. No, it's just, come on, better than that. Let's improve. So be professional. Come on, better. Sticking to a definition of done is a really good way. So as a team, we've said we're going to do this. You're not doing it. Come on. Work with us. Yeah, question?
So I feel you gave us a definition of what technical debt was not.
Yep.
But maybe I was asleep, but I didn't actually hear a definition of what technical debt actually is.
Immature code. Code that doesn't reflect a full understanding of the solution. Well-written code that's an incomplete implementation.
Isn't that a prototype?
Sure, it is. If the prototype is well-written code. Because most prototypes aren't. Most prototypes are slap it together and whatever. Yeah, and then that's production code. Yeah. All right, what we might do is, just given the time, I'm going to let you guys run off to, is there another session immediately or have we got a break? Lunch now? Already? Well, whatever it is, go to the next session. If you want to ask questions, come up the front. I'll talk to you guys soon.